Nice. So now what do you do?
You go down.
Main screen. Yep. And then what do you do?
You do the, is it end derivative?
Yeah, what is that? Where do I find end derivative? Math.
Math 8, right?
I think it's math 8, yep. And then you put x down there. Yep. And then what do you put right in there?
Y1.
Y1, so you do y bars. Do function y1, and then at x equals what? At 5, right?
Yeah.
At 5. So at 5, and then you just press enter. And then do you get the exact same thing? Yeah, you do. Look at that. So on these, you have to use your calculator, because what's the only other, there's another method. What's the other way you could use your calculator to do this one, the longer method? We did it for like weeks in this class. What did we learn? What did we do to find derivatives first, everybody?
Oh,
Limit definition of derivative, right? Could you theoretically use the limit definition of derivative and then make a table? Yeah. We did that a bunch. You theoretically could, but now you have n deriv, so you can just evaluate it this way. Nice. Okay, what else? First thing you should really pay attention to on this, I want to point this out to you, is bases, when they are different, make it a little bit more work for you. So what are the two bases here?
7 and e.
7 and e. They're not the same number. They're also not factors. They're not nice powers of each other. Like you can raise e to a power and get 7, but it's not a nice power, right? The point is you could put this in log form. You could use this method, or what can you do to both sides? You could take the log of both sides. And why on this one? In the exponent. And taking the log, one thing that's nice is it allows you to move those exponents down. So what's our proposed first step, Noah?
Take log of both sides,
or take the
ln.
Do that. Tell me where you get to. Do ln of both sides and tell me where you get to. Do that first. Okay, so pause. One of the biggest mistakes people make when they work with logs is they try to do too many things at once. People think logs are hard. They're actually phenomenally easy. You just have to only do the things you're allowed to do. The number one mistake people make with logs is that they make stuff up. I understand you don't realize you're making stuff up. So I understand what you were saying there, but let's just be precise. The ln doesn't cancel the what is ln e? What is ln e? That is 1, right? And do you see how many people put parentheses? Oh, all put parentheses aren't, oh, you got to put parentheses aren't x plus 2 right there. So what do you end up with now? X ln 7 plus 2 ln 7 equals what? 17x. Finish it for me. So if you're isolating x, what should you put on one side? Everything with a x in it. Right, exactly. So x ln 7 minus 17 is equal to negative 2 ln 7. What do you factor out? Yeah, x times ln 7 minus ln 17 equals negative 2 ln 7. And then what do you get? X is equal to what? Negative 2 ln 7 over ln 7 minus ln 17. How's that? Is that pretty good?
I'm sorry, is there, I don't think there's an ln, unless you put it there for 17.
There is.
There was.
There has to be.
No. There wasn't.
Did I make something up?
Yeah.
Oh.
7's supposed to be on the bottom.
Oh, this should be what?
17.
Just 17. Yeah, sorry. I just put that in there. Sorry. It's just this right here. Is that it?
Oh, yeah.
Yeah, it's just 17.
The way we did it is wrong.
You're not done yet. You're correct. What's wrong? You have the exact. There's no ln in front of the 17. You did the same thing we did. Because look, over here, it's just 17. Okay. The challenging aspect to this one is the fact that x is in both the power and the power and the base. The power and the base. That is one challenging aspect to this. That's one challenging aspect to this. So try a few starts on this. See if you can just try something and go with it and see what happens. Try something and go with it and see what happens. You guys took ln of both sides. You need to show all steps. None of you showed all steps. You just went to the next thing, because I can guarantee this will kick you hard. Oh, it's still frozen? Yeah, that happens.
I'm just doing it like this.
I know. Just leave it like this. Let's see how long Mr. Seamon will go. Okay, so you take the natural log of both sides. You actually do the natural log of both sides, like this. And then what happens? You have ln of 2x minus 1 equals ln x squared ln e, like this. Yeah. But what is ln e?
1.
Yeah, so it's ln 2x minus 1 is equal to ln of x squared. If log a equals log b, then what has to be true? A equals b. So therefore, 2x minus 1 is equal to? So you have x squared minus 2x plus 1 is equal to 0, which is X minus 1 squared is equal to 0, so x is equal to 1. Okay, there's your log review for today. A key term here. Find both the continuous rate and effective rate for each of the following. Continuous and effective. Okay, do you remember yesterday when we talked about compound interest? It was yesterday. Was it 2 days ago?
Yes.
2 days ago, right? Compound interest. If you took 12% and did it once, or you did 12% or you did 1% 12 times, that's compounding monthly, and then we compounded daily. What happened as you compounded interest? It increased the yield, right? It increased how much money you made. Do you get an infinite amount of money? No. There was that limit, which was continuous interest that I did with a PERT. Do you remember that? So the point is you can compound interest and you make more money than if you just did the interest once. So if you did $10 and at 12% once, how much money would you have at the end of the year? 10%, so $10, 12% interest once. How much money would you have? $11.20. How'd you get $11.20?
12% of $10.
Yeah. So you did this, right? Not that. 1 point what? 1.2, right? And ended up with $11.20, right? What happens if you wanted to compound that monthly? Compound that monthly, what would it be? 10 times 1 plus 0.12 over what? 12 to the what power? Do that on your calculator for me. Do that right now on your calculator. Everybody do that right now. 11.26 what? Give me more. 268. Okay, 82. Good. So here's the thing. Effective interest is, simply put, what would the interest rate need to be to get what you get in 1 year? So what's the effective interest rate for this one? The effective interest rate on this one is 20%, because you do 12%. 12%, because how much interest do you need to earn in order to get $11.20 from $10 in 1 year? Well, that is the problem. It's 12%, right? What's the effective interest rate on this one? What's the effective interest rate on that one?
Would be 1 plus 0.12 over 12.
So you have to. What do you multiply 10 by to turn it into that? What would it be? What do you multiply 10 by to get 11.2682?
1 plus 0.12 to the 12 pounds. Right?
It's there. You can tell me the number. What do you multiply? Ignore this now. What do you multiply 10 by to get 11.2682?
12.6.
What?
Oh, to get that.
What do you?
1.126.
Yes, 1.12682. That's what you multiply it by, right? What do you multiply 10 by to get 11.2682?
Wow.
You get that, right? What is the percentage increase right there? What's the percentage increase to go from 10? What's the percentage increase to go from 1 to this? What's the percentage increase? 12.682. This right here is called the effective interest rate. So if you compounded 12% monthly, that's the same thing as doing 12.682 once. Remember, it's always going to go up a little bit. Is everybody with me so far? So the reason effective interest rate is so important is it always apparent which interest rates are going to give you more money? Really?
Is it what?
Is it always really obvious which plans? Is it always really obvious? No. So when you're buying a house or a car, they might say, okay, you get 3% interest rate on this over 6 years compounded continuously, right? Or you get $2,000 cash back and 4% interest on your loan, right? So you're getting a higher percentage rate loan, but you're getting more money back in the beginning. So to a regular person, even a math person, when you look at those loans, is it really easy to figure out which one is it hard or easy to figure out the best loan? It's usually pretty what? It's pretty hard. I mean, you look at those ads on TV, is it easy to compare them? No. How do you compare them? What do you compare them with? We literally just did this. The effective rate. You compare them with the effective rate. So I could tell you, do you want to pay 12% interest compounded monthly on your loan, or do you want to pay 12% yearly? Which one do you want?
Yearly.
You want yearly because you would owe less money, right? Because conclusively, how do you compare them with the what? Effective rate. Or I could say, well, it's going to cost you $9. But you have to pay continuous interest. Is it obvious which one is better? No. So you're paying less money to start with on your loan, right? You're owing less money, but the interest rate is more powerful. It blows up faster, right? But does it blow up faster than that? So you need a way to compare exponential growth. Is everybody with me so far? So you're going to answer the question, what interest rate would you need to take once in order to have the same growth rate here? So let's look at the two things here. Let's look at the two, and I'll move this over to the side. Look at those two for. Does that look really similar to what we just did before? Where did you get 15% from, Chris? Where did you see 15%?
Just the
0.15 minus 1. You take a 1 away, right?
Yeah.
So if it's in that form, is it really easy to find the effective interest rate? Absolutely. Every year, right there, if X was in time in years, it would go up by 15%. Let's go over here for the other one. So what do we need to look at? E to the what? 1.25t. And you're like, oh man, that t is there.
That's compounded like multiple times.
It's like more than one time. So what do we do here? There's an exponent rule. How can you pull those exponents apart? What could I do?
You can separate.
There's no equal sign, so we're not going to take anything. That's a good guess. It's actually a really safe guess. Just take ln. It's what he said before. Just do it. Just do it. It's like in my AP calculus class. If you're ever lost, I think I've told you this, take the derivative, set it equal to 0, and solve. You'll do that like 10,000 times. Do you remember what powers of powers do? They multiply. You got it. Powers of powers multiply. So what does e to the 1.5t equal? E to the 1.25. To the what? Do e to the 1.25 for me. Just someone do that for me. It's 3 something, I think. 3 something. What do you get?
3.49.
3.49. Give me more. 3.49.
0.3.
0.3, thanks. And it goes on, but to the what power? T. Do you agree that those two things are the same thing? Is this the same as this?
Yeah.
Is that the same as that? Okay. So what do you think the effective interest rate is here? What do you think the effective interest rate is here? Be really careful. What do you think the effective interest rate is? 249%. Yes, that would be the effective interest rate. You agree so far?
Well, how did you get that?
Where'd the 2 come from? Natalie, how'd they get the 15% right there? 15% was how much greater than 1, right? Yeah. So over here, how much greater is 3.4903 than 1? It's 2.49. So the R is 2. What is that in percentage? 249%. So we've done half of this so far. This right here, these are both the effective interest rates. The effective interest rates. Nice. So what does it also ask you to find on this question? What does it also ask you to find? So if these are the effective, the continuous would be, what would the interest rate be for this to be a term continuous interest? Now one of these is in continuous interest form and the other one is in regular interest form. Which one's in continuous interest form? A. So what's the continuous interest rate here?
1.25.
No, careful, the interest rate is not 1.25.
25%.
Is it 25%?
No, it's 7.
Careful, remember, the entire interest rate is up there.
Right.
So what is it?
1.25.
125%. 125%. For the continuous interest rate formula, the interest rate is just there. Is just there. So is that in continuous interest rate form? What's the formula for continuous interest? What is it? A equals PERT, right? Do we have some of that? What's the p-value?
10.
So we have, and I don't really like the fact that p is there. I should have changed that. So we can change this a little bit. We want to make it, so p is equal to 10. We want it to be e to the x, right? But what do we have instead?
1.15.
Yes, we want e to some power right here, right? We want e to some power to be 1.15. Instead of question mark, what letter do you want to use? Pick a letter.
B.
B? Sure. We want to turn it into PERT. EA. So what's our initial value? 10. So what equation do we set up? E to the B has to equal what?
10.
Nope. The 10 is already there.
1.25.
1.15. Yes. You want to know 1.15 is e to what power? 1.15 is e to what power? You with me so far?
Yeah.
So how do we solve that? You guys are really good at this now. What should I take on both sides? You guys like this method better, apparently. Take ln. It's actually really good to take ln in this case because what's the base? E. When you see e's, use ln. So what do you have? ln e to the b is equal to ln of 1.15. What do you bring to the front? So b ln e is equal to 5. So what does b equal? Can someone do that? What is ln 1.15? Do that for me. What do you get? It's going to be less than e or greater than e. What do you think? Or less than 1 or greater than 1?
0.1397.
1397. Why is that? Why does that make sense? Well, e to what power is 1.15? Is 1.15 less than or greater than e? What's e to the first power? E. Well, yeah, 2.718. Right, exactly, right? So if you wanted to get a number smaller than e, you have to raise it to a power less than 1. So that's the b value. Let's plug it back in here. So what do we now know the equation is? P is equal to 10 what? E to the 0.1397x. So can you tell me what the continuous interest rate is? What's the continuous interest rate? 13 point what?
97%.
Ah, very cool. So we just showed that a 15% effective interest rate is the same thing as a 13.97 continuous interest rate. Why does it make sense that the continuous interest rate is less than the effective? What's more powerful? Continuous is more powerful. Continuous earns you more money over time. So if you want to earn the same amount of money compared to an effective interest rate, which is yearly, it should be lower. This allows you to compare plans here. This allows you to compare plans. Okay, let's keep moving here. Okay, you guys did a really good job starting. You have y equals ab to the t, right? You know that? So what's your first goal? Oh, thank you. What's your first goal? What's your first goal? Find what? Find b. Find b. So what did we know? The half-life was what? 20. So you know you have half of a left after how long? To the 20th power. After 20 iterations, you have half of a left. What cancels? A. So this is what we did 2 days ago. B to the what? So b is the 20th root of 1/2. So at this point, what do you do? Write the new equation. Y equals a times the 20th root of 1/2 all to the t. Some of you did the decimal for this. Some of you did the decimal. Anybody do the decimal for this?
Yeah.
What is the decimal for this?
0.9659.
0.9 what?
9659.
59 to the what? To the t. And remember what we talked about just a minute ago? Does the a value have anything to do with the effective interest rate?
No.
No. So we're not doing the continuous one, we'll do the effective one, right?
Yeah.
What's the effective interest rate going to be on this? The effective interest rate is what the difference is between 1 and whatever is underneath the what? So what's the effective interest rate going to be? Negative what? It's decay, right? So it's going to be whatever this is, 1 minus 0.9659. What is that? So it's 3.4. Is it 3.41? Is it 3.41? So what's the effective interest rate here? What's the effective hourly decay rate? Effective hourly decay rate. So this is the effective hourly decay rate.
Isn't it just positive because the decay rate? So
yeah, you could say that. You could say if you said the decay rate, that totally true there. But the effective, yeah, you're right, because it's awkward if I say the effective growth rate is negative. Either way, I would accept that. The effective decay rate is 3.41%. But if you want the continuous, what do you have to solve for? E to some power is equal to what? 0.95. Sorry, 96 what? 659. What should I take on both sides for this one? ln of e to the b is equal to ln of 0.9659. So b is equal to ln of 0.9659. Can you do that for me? What is that? I'm giving you a gift. I'm just giving this to you. The derivative of a to the x is ln a times a to the x. The derivative of a to the x is ln a times a to the x. So what's the derivative of 3 to the x, Chris?
3 to the x would be ln 3
times
3 to the x.
Yes, done. What's the derivative of e to the x?
ln e.
It's e to the x. The derivative of e to the x is ln e to the x, but what is ln e? Is 1, so it's just e to the x. So what's the derivative of e to the x? Itself. That's one of the coolest things about that function. The derivative of e to the x is itself. I am giving you this. This is awesome. It's really straightforward. The derivative of a to the x is ln a to the x. So what is f prime going to be on this one, Lindsay? What is the derivative of 2 to the x?
ln 2 times 2 to the x.
ln 2 times 2 to the x. Yay! Noah, what's this one? What's f prime of x on this one going to be?
ln 4.
ln 4, we're getting a lot more.
Yeah,
There's an ln 4.
4 to the x.
There's something missing. 5.
Oh,
The 5 is just along for the ride. I put parentheses around there to emphasize that. The 5 is just along for the ride. It doesn't affect really anything. Oh my gosh, this looks impossible. What am I going to do? Mr. Seamon, this is terrible. Anybody want to help me with this one? What's f prime of x on this one going to be? What's the derivative of pi squared? Come on.
ln pi times.
Careful. Pi squared has no variable in it. What's the derivative of pi squared? What's the derivative of 7? What's the derivative? What's the rate of change of something that doesn't change?
0.
0.
And
That's so common.
you're like, no, no. So what's the derivative of pi squared? 0. Yeah. What's the derivative of pi to the x? ln pi times pi to the x. What's the derivative of negative x squared?
ln x.
Pi x squared. What is the derivative of x squared? It's like the first. It's like the first thing we ever did. What's the derivative of x squared? Really?
X.
Okay. We're gonna stay on the record here. Come on, you got it. Come on. What's the derivative of 2x? Yes. Okay. The reason I'm throwing you this out at you is because just because we learned something new doesn't mean that everything else goes away. Okay. Okay. So that right there, the only thing that's new is the middle term. Okay, the next one, 3 over x squared. How can I rewrite that to make it like something we can take a derivative of? 3 over x squared is the same thing as 3 times what? X to the negative 2. Can you tell me what the derivative of 3 times x to the negative 2 is? Negative what? Negative what? Negative 6 times x to the negative 3. And it's hard to see this. That's 8 to the 1 plus x. What's the derivative of 8 to the 1 plus x minus what? This is the new rule.
Oh, that's just
ln
ln
8 times 1 plus x. All done. So what are the only new things here? This one going to this, and this one going to this. Everything else, what is everything else?
That's the older stuff.
It's old stuff. It's old stuff. Old stuff. Now, there's another hint here, everybody. You see this one right here? See that hint? What does that change? Let's just check this for a second. What does this 8 do? It's just along for the ride. What's the derivative of 8 to the x? ln 8 times what? 8 to the x. What can you tell me about these two things? What can you tell me about those two things? They're the same. They're the same. Because what is 8 to the 1 plus x? 8 times 8 to the x. So are they the same? They are the same. They are the same. They are the same. Oh wait, we talked about this one. What's the derivative of e to the x? Yeah, because this is ln of e times e to the x. I like you see those parentheses I put around it? Why is it really important to me to put those parentheses around it? Well, it identifies it turns into 1, but it also keeps it separate from the e to the x, and you don't play that power. Okay. Excellent, excellent. Let's find this here. Okay, get back to the board. Try to find somebody you haven't worked with today. Everybody.
Oh, yeah,
Tangent line means find slope and point. All this is slope and point. So what does y prime equal? You guys did it great. It was ln 3 times 3 to the x. So what is y prime when x is 2? ln 3 times 9. So then what is the function when x is 2? Well, that's 3 to the 2, which is 9. So what's the point? Here's your point, and there's your slope, and there's your point. So you have y minus 9 is equal to ln 3 times 9 times x minus 2. Generally speaking, I would like to see this. Oh, there's your time. You did it early. I like putting the coefficients first like this. That would be a great way to finish it right there. Awesome, awesome job. You guys